Welcome students, this is lesson 58, section views. We're going to go over activity 7.2. This is on the day of Wednesday the 10th and Thursday the 11th. That is my son's first birthday, by the way. Also, you might notice that I am wearing my Razer headset for the first time, courtesy of Mr. Aiden in first period. So thank you, Aiden, for donating these to the Hulsey Cast Fund. So I'll skip all of this stuff. Good luck on the star this week, you guys. Let's see. Today's agenda. Yes, we will take the vocab quiz after you watch this video and come to class. And then we'll do the lecture and the activity for this. So first, we're going to talk about some alternate views. There are three. These are vocab words: section view, auxiliary view. By the way, this can be pronounced auxiliary if you want. I say auxiliary. And detail view. Definitely get these written in your engineering notebook. Okay, here's the first little example of a section view. You use this cutting plane line right here to cut through this this part, and then you look at it the way that the arrows are pointing. So this is kind of, if this is a top-down view, this is kind of from this side over here, looking this way. Okay. You use that cutting plane line. Like I said, this is a dot dash with arrows, and you have these letters here, AA, so you can specify section AA. And then wherever you cut, imagine that this whole thing is alive, and then you cut it, and that's the wound. So the section lines go on the wound. That's how I like to think about it. Okay, there are three types of section lines. Get these in your notebook too. Full section, half section, offset section. The full section is the one we talk about first. That's what you saw before, and that's what you'll see now. Here is the full section view. This might be the top-down view, so this is the top view. And then here's our section line, cutting this way, and we're looking at it in this direction. So here's your first question. Tell me, if this is the top, tell me what view this is. Okay, so if this is the top, here's a big hint. This is over to the right, so this should be the right view. We're looking at kind of some big object that has a hole in it. It's hollowed out. It's a hollowed out cylindrical object. So here's another question. Look at this hidden line right here. This hidden line, that's 1, 2, 3 lines out from the center. Oh, I guess 4 if you count this one. Out from the center. That hidden line, what is the diameter of that hidden line? Okay, so it should be this 2.5. And that makes sense because if you look at it from the top down, this line right here, where my mouse is, this 2.5, that one is actually hidden or underneath some of this actual material here. That's why it's a hidden line when you look at it top down. All right, that's a full section view. Let's talk about a half section. It's the same thing, except we're only cutting away half of the half that we cut away. So it's really a quarter. We're cutting away a quarter, but we're on our actual section view here, we're leaving half of it solid and half of it sectioned out. So let's study this a little bit. It makes sense if we look at it and compare this isometric to this section view. Let's look at it from this side, basically. So we see this section. This is the wound. So where all these section lines are, that's the wound here. And then we have solid material. So we have 1, 2, a little one, a big one, and then a smaller bump. So we have 5 bumps. 1, 2, a little one, a bigger one, and that one. Those are bumps there. And then the section view has this Z-looking thing, a thin part, and that makes sense here. Z-looking thing, a thin part, and then fat, and then thin again. Fat, and then thin again. So that's different. The section view is a little bit different from the solid features. You can tell that the whole is different than the solid sections right here. That's why this is very useful, because you can see both of those in the section view at the same time. And again, with this cutting plane line, the cutting plane line cuts away a quarter of it, so that tells us what direction we're looking at it onto. Okay, and an offset section is kind of the same thing. As those other two, but this time we're cutting in different areas. Like if we have holes that are all in different locations from each other, we want to cut through this hole, through this hole, through this hole. We can just do a section line that goes offset through all of those holes, right in the middle of all those holes. Now, where the cutting plane line goes into and out of the cutting plane, I guess you could say, parallel to the arrow of the cutting plane. Parallel to the arrow of the cutting plane. What kind of line does that make? Yeah, if you look at the section view, that makes an object line. And that makes sense. If you slice it that way into the plane here, when you look at the cutting view, you see this wound is going to be closer to you than this wound back here. This one's going to be closer too. So there's a drop off here as you're looking straight onto it. That should be an object line. Okay, auxiliary views, we're not messing around with a whole lot, but basically if you have a slanted face, some of it gets foreshortened. So look at this, here's your next question. I have this section on the left, I'm going to call this the left section, I'm going to call this the right section. Which one is elevated, the left or the right? Yeah, it took me a while to figure this out because you have a hole going down here and then a hole going across here. So this across line, or this across hole, is this one here. So this part is elevated and this part is flat. The left part is flat and the right part is elevated. But when you look at those, it's foreshortened. It's not exactly what you see when you look at it. It's shorter, so the dimensions are kind of skewed. It's going to be hard to dimension a part like this, so those auxiliary views come in very handy. You can look at this slanted face straight on. So now the foreshortened view, the foreshortened face is this one here. That's not foreshortened here. The foreshortened face on the front view is this. And then we just switched them. We looked straight on to this face with a foreshortened face here. We substituted that straight on face for this foreshortened one. Okay, let's talk about detailed views. Pretty self-explanatory. We take a section of our piece. Maybe there's a lot of detail going on here that's very small. We don't want to dimension all of that in a very small area, so we just cut out one of those little teeth on this part and then we enlarge it for clarity. Okay, this next section is talking about holes. Let's talk about some holes. Here are some definitions for you. Through, a hole that cuts through goes through the entire surface. You can see it on the top and the bottom, and if you look through it, you can see somebody else's eyeball. Clearance is a hole that goes all the way through without anything on the top. Okay, so you can actually drop the screw head all the way through it, or the driver. Blind hole does not go all the way through. So if you look on it, if you look straight down into it, you should see dark and not somebody else's eyeball. Countersink and counterbore are the next two words. That's where the screw head sits inside the part, so it might be flush with the surface on top. There's a big difference. Countersink is conical. Okay, countersink is a conical hole, and then counterbore is flat. So if you have a screw head that's flat with basically a fat cylinder and a smaller cylinder, that's good for a counterbore. If you have a conical or a cone on the top, you want a countersink for that. Tapped just means that it has threads on the inside, so you can actually screw your screw into there and it'll stay. There's a big difference between a spot base and a counterbore. A spot base is a new word that's kind of not that important unless you get more advanced into this stuff. Spot face just means if you have an irregular or uneven surface, you can drill an actual manufactured piece. You can drill this spot face, or it's basically like a counterbore on an irregular surface. You can drill that out to where, look at this, the screw head will sit actually flush into the bottom surface here and not sticking out where there's a big gap. So spot face is a counterbore on an uneven or irregular or curved surface. All right, let's talk about when we put holes in. We got some notes here. I would definitely get these in your engineering notebook. Diameter, counterbore, countersink. Yeah, counterbore or spot face have the same symbol. Countersink and depth. Okay, let's look at an example hole here. We have basically 4 numbers. If you have a countersink, a counterbore, you have 4 numbers. The diameter, the depth, and then the diameter and the depth again. That's because, like I said, you have 2 cylinders. A fat one, that's the counterbore, and then a skinnier one, that's the actual screw hole. So it's pretty easy. You just look at which one's bigger. Well, this one's bigger in diameter, 0.38, so that's got to be our counterbore diameter. That makes sense. It goes next to the counterbore sign. And then the depth is a lot shorter, so that counterbore is only 1/4 inch, or as your whole screw. Let's do this: 1/4 inch. Your whole screw, 1/4 inch for the counter bore. Your whole screw is 3/4 inch long, and it's only 1/4 inch in diameter. That's the whole screw. That's the screw diameter. Okay. Here's another note. That must be a regular hole without a counterbore or countersink. And this says that it's blind, and that makes a lot of sense here. It's not very intuitive when you just look at it, but if you notice that this one says through, then you'll know that this one is blind. And that's why I really like your extents on extrusions, especially with holes, to instead of telling me a set distance that's equal to the thickness of your part, which is the same as through, go ahead and say extents is through instead of a set distance. That way your diameter, excuse me, your drawing will tell me through as well. Okay, yeah, because this is what it says, through. Okay, here's another whole note. This is a little pop quiz. What symbol is this here? What kind of screw or excuse me, what kind of hole are we giving here? And the answer is a countersink. That's not too hard if you remember the symbol. Now tell me, is that conical or a flat surface for your head, for the screw head? Yeah, it's conical, and that makes sense with the symbol too. It's pretty intuitive there. Okay, let's talk about some threads. This is the last little section here. Threads, we have two different styles of notes. Unified national, think this nation, the United States. What system are we using, metric or customary? Mostly customary. So unified national is for customary, ISO is for international or metric mostly. So right here, this is unified national, and you always get a UN at the end here, and then you have a C or an F, coarse or fine. There's really mostly two distinctions. This number at the beginning is the major diameter, and we can talk later about major versus minor. And then this is the thread count per inch. That's kind of like a pitch measurement there. Don't worry all that much about all this stuff. You don't have to memorize it a whole lot. You just need to be able to read these, especially if you're going to go out and buy some screws, or if you need to know exactly what threads you have on a part and you want to model those. You need to know how to read this type of thread notes. Here's the other type of thread notes, ISO. There's a lot more to it, so just write down thread notes is in P58 for reference. Thread notes is in P58 lecture. So ISO, you have M for metric, and this is a nominal diameter in millimeters, right, for metric. This is in millimeters, so 12 for nominal diameter. Then this is the pitch, or the pitch of the threads. That is the distance between each thread, so between each revolution of the thread. So if I start here, go around, let me do it sideways. Start here, go around, and then come back to the same height or the same spot. Then that distance between the two spots right here is 1.5 millimeters. Okay, then 6 is tolerance. We'll get to the tolerance later. H is allowance. We'll get to allowance later. No allowance or tight allowance, that means that it has some wiggle room or not. And then, of course, through at the end. Okay, let's talk about this assignment, 7.2. Don't forget to read the introduction on your own time. Let's look at the equipment we might need, our engineering notebook pen, and I actually have a paper handout for you that I printed. Don't forget, if you want to use Inventor Professional 2018 at home, it has to be the 2018 version in order to be compatible. Look on my Schoology updates for how to get that. I put that out a couple months ago. Several months ago. Now, this is the first item in the procedure. I'm going to go ahead and walk you through this. It shouldn't be incredibly hard, but I'm just going to demonstrate. Create a solid model of the drill block pictured here. I'm going to put all of our holes in here. Don't forget, on this document, you can always click on these drawings and make them bigger so you can see the notes a little bit better. You go ahead and do that on your own document. You'll place a photo in here. Next, questions 2 through 4 are on the paper handout. That's why I printed this off, because I want you to draw these section views. Draw a section view for 2, 3, and 4. And then for the bonus, you will create isometric views and sketches in your notebook and place the photos of those here. On this one, you will make some more sketches in your notebook of this product, and then you will create this product in Inventor and then place the drawing file here. Conclusion questions, don't forget about those. You need to do all of them. Now let me jump over to Inventor. Okay, here's my Inventor. Don't forget to create a new project, always new single user project. Next, I actually put in a flash drive so it looks a little bit more like yours. Go to this PC, This should be your network driver. It should say your name here, Inventor Projects. You want to create a new folder here. This will be activity 7.2. Or you could, inside unit 7, you could put that folder in there. That can go next to your 7.1 folder, however you want to do it to make it more organized. But you do need a dedicated 7.2 folder. Make this activity 7.2 underscore project underscore your initials, not MBH. If you're, Hudson Blaze Hulsey, it would be HBH. If you're Michael Bailey Hulsey, MBH. Your initials need to go on the end of every file, actually, not just the project file, but every file. Okay, finish, done. Now we're in a new project. You see location should say H right here, not D. Should say H. That's how you know you're in your H drive, and you can always access your parts and stuff. Okay, so a new part. We're going to do question 1 of this assignment. Excuse me. We're going to do question 1 of this assignment way up here. We're going to create this drill block. So we look and we see that it's a 3-inch in depth by 5-inch in width by 2-inch in height. So I like to sketch, let's ignore this error. I like to always sketch on the XY plane. So we'll look and we'll see that this is width and height. That's a 5 by 2-inch piece there. And that can go on my XY plane. 5 by 2, and it doesn't, oh whoops, let's go back inside my sketch. It doesn't really matter if you put it right at the center, but you can if you want to. 2-point center, that might come in handy later. 5 by 2, that might be your adventure tip for the day. 5 by 2-inch there, okay. And let's extrude that. And this way, if you want to make it centered, if you want the center point to be exactly in the middle, you can extrude both ways symmetrically. So it'll go in the front of your sketch and behind your sketch. That'll be a 3-inch extrusion there, 3-inch in depth. Okay, so we have that drill block. And in the front, we want to put our holes. To put these holes, I would probably do a sketch on the front here. And then I put my points because I want to use the whole tool. That would be a lot easier. So I can put some points here. I have, let's see, 4 holes. I'm not exactly sure where they are. I can just put them here for now and then dimension them afterwards. Okay, I think they're all on that center line, and I tried to put them on the center line. Yeah, if you zoom in close enough, you should see. If you're not certain that they are, you can always give them a horizontal constraint to the center point. Okay, and I can hit F8 to show my constraint, so I know that that one's horizontal. Let me go to horizontal again. I know now that that one's horizontal. Let's see. Oh, that already exists, so that one is horizontal. There we go. I hit F8 again. I know that this one's horizontal. When I say horizontal, I mean it's all horizontal to the midpoint here. They're all on the same horizontal line. In other words, this axis. I think it's the x-axis. Okay, so there, everything's there. Let me turn those constraints off with another. Actually, F8 doesn't toggle it. You have to hit F9 to go off. F8 on and F9 off. Okay, so those are all in line. Now let me look. I got chain dimensioning here. So let's do dimensions from here to here. And you don't have to worry about good dimensioning techniques when you're creating parts, just whenever you're documenting them. So this distance will be 0.75. This distance from here to here will be what? 1 inch. This distance from this center hole to this center hole will be 1.25 inches. And this distance from here to this center of the hole is 1.25 inches, and that now they're all purple points there. Okay, if we finish that, now I have the centers for all these sketches. I can move that over. So now I want to do holes. Where's my hole tool? This is where the hole tool really comes in handy. I don't actually want to use all of those centers, so on my centers I can hold control. I can hold control, but it won't work. Hole, I just want one of them. Let go of all my others. On point. Okay, that's better. And then it lets me select the points. I think it'll let me select the friggin' points. Oh my gosh. From sketch. But I don't want to do all of those at the same freaking time. I just want one center. Can I click? Can I unclick? Can I unselect? Can I click that? Undo, undo. Not undo. Oh, I figured it out. Shift, click that. Okay. Now I have to cut the freaking video and do this over and edit the whole thing. Okay, so if you create this right here, let's do hole. And you see, oh no, it wants to take all of my holes. Don't do that. Make sure you have this button selected, sensors, and then we'll unselect them by holding shift and then clicking our points. Holding shift, clicking our points, and you can see when they turn yellow, they're going to be unselected there. Okay, so this one, let's see what our dimensions are for it. It's going to be, and like I said, you can make this bigger so you can see the hole notes. That's going to be a 0.5 inch hole and a 2-inch depth. So that's going to be a blind hole, and we want to put a counter bore in there. So we want this selection here, the solution counter bore. Alrighty, so for the thickness of the hole, we want that to be a 1/2 inch. That's this thickness right here. We want it to go down a depth of 2, so termination distance, I want that to go 2 inches in. And then the counter bore will be a diameter of 0.75 inches, and then the depth of that counter bore is 1/2 inch. I think that's everything. It doesn't specify the ending point or the drill point, so typically it comes out at 118 degrees. That's just how a lot of drill tips are finished at the end. You can make it flat at the end, but it doesn't really matter because it's not specified here. It kind of does look like it's curved, it's conical inside there from the look at this, but we can't really tell, so we'll leave what we have. Okay, that one's done. Uh-oh, my other points went away on that sketch, so let me make this sketch visible again. Okay, and let me go back to hole tool, and oh no, I tried to copy the whole thing, so again, I can hold shift and unselect all of these, and now I can re-specify my hole dimensions and everything. So this hole, we see that we've got a countersink this time, so we want to use a countersink. Here's a spot face, but we're going to use a countersink. Okay, we want it to be 82 degrees and a countersink diameter of 1 inch, so that's 82 degrees. I guess that's a standard. And a countersink diameter towards the top at 1 inch. Okay, that looks pretty big, which it should. And then the depth of that hole is, oh, that's through all, so that's that termination. We want that to stay through because on our documentation it'll actually say through. And then the diameter of that hole is 0.5. Yep, there we go. Okay, so that one's done. Again, we'll do a hole. We'll unselect this one. And now for this guy, oops. For this guy, oh, it's just a clearance hole. No counters, no countersink, no counter bore, just a drilled hole. The diameter is 0.5, and then it has, look at this, plus or minus 0.002. That's a tolerance. We're not really dealing with tolerances yet, so skip that part. That's just a 1/2 inch diameter through all hole. Okay, apply that guy. Oh, and then if you hit apply, it goes to the next hole. That's pretty nice. Next hole is a counter bore. Okay, counter bore, and we'll do a 0.25 inch diameter. That's the hole. 0.25 inch diameter there. That's a 1 inch distance hole. Okay, and then our counter bore has 0.375 in diameter. 0.375 in diameter, and then the counter bore depth is a 1/4 inch in diameter. 1/4 inch in diameter. Okay, and again, we'll leave our drill point at an angled point termination at the end. Okay, apply, and there are no more points to apply our holes to. So we got that done just like that. And I think if we look at this, it looks pretty much like it does here, except this is a little bit darker. But oh, if you zoom in, it looks a lot better. It looks a lot more like it. Okay. And oh yeah, this is definitely the center because it's 1 inch here and 2 inch here. Next, we need to create a drawing file. Oh, let's first save this, of course, in A's 7.2. Let's call this A's 7.2.2 underscore your initials, and it'll save as IPT. Let's save it. Okay, now when we file new drawing IDW, make sure we're in inches here, create. Now when we create this, and we place that part in, it'll when we hit place base, it'll create that part that we just created. So here are the steps again. Let's delete this large ANSI block because we want to change the size of our sheet. It comes out default as a poster, size D poster. We want to change it to a size A, 8.5 by 11. Then fortunately in our resources we have a good size title block, an A size title block. We want to double click that and insert it into our sheet. Okay, so now that you have an A size sheet, you want to place your base view in. And now watch this. If I place this top and right side and isometric, all of that in there, it looks kind of funky because I have all these holes that are upside down and hidden lines. And this doesn't really tell me anything at all because I have way too many hidden lines. So those aren't even helpful views. We can just delete here. Or you could just, control. I think control Z is the coward's way out. And then if we want to move a view, grab the edge of it, okay? Remember, you can't have any other tools selected. You can't be in the annotate dimension tool or anything like that. Okay, so we want a section view that cuts right in the middle and goes upwards. So we can do a section, and it's pretty simple from here. We will if you have multiple views, you'll have to select this view to do the section on, but since I only have this one, it's going to go ahead and do it. Look, it suggests that I do it right in the middle, which is very smart of Inventor. I do want to go right in the middle, and I do want to go across, and you can see this constraint showing up that's parallel. Make sure your line's parallel. Hit there, and then, oh no, I have so many lines. That's too many. Right-click and hit continue. Now that I've done my section, you can tell it which direction you want your cutting plane line to go. And we want ours to go upwards, right? Yep, upwards. So that way our view down here can show our holes going into the thing. Over here you see view identifier A. The scale should be the same as your other scale. And then, yeah, it'll create the AA section just like we wanted. Uh-oh, my words are going into my title block again. I can move this whole thing up a little bit. And then, let's see. When you finish, insert a screenshot of your drawing file. Yeah, you need to fully dimension this multi-view part file. So basically put the dimensions that you see on here onto this. And you go to annotate, dimension. I believe the hole will already be created. No, you need to say hole and thread. So if you say hole and thread and then pick that center, yeah, all of that hole information should show up. Okay, hole and thread for the center. Oh yeah, we got lots of holes. Make sure you don't go up and down for these leader lines. You want them to be offset a little bit. So you can move these, and usually to move things you have to not be inside any tool, any other tool. Let's click on that point. Yeah, you can kind of mess around with this. Yeah, and then add all those. This is chain dimensioning. Don't add the last chain there. Then finally take a screenshot of all this and you'll be done with question 1. And here we go. This is question 2. So we want to draw a section view here. This is what's already shown is the top and the right. We want to draw a front view that is also a section view. So let me cut all of this. Before you do that, I would recommend taking a ruler and drawing all of these little lines down into your view, little construction lines down. So I'm going to do that, cut my screen, and come back to you. Okay, notice how I drew everything. I mean, I'm talking everything. I did, let's see. I did these lines, the solid lines. I did the center lines, and even for that circle, I drew lines all the way down. For this circle too, all the way down, and then for all of these features all the way down. Do the same with these features over here. Go ahead and take all the lines you can see that are up and down and take them across. Let me do that. Okay, and remember, you're using your ruler to do this. So I counted 1, 2, 3, 4, 5 lines about. Now I'm going to take my object lines. I'm using a different color here and making it a little bit thicker. And you can tell that it starts from this corner here, goes up to this corner here, and then these two corners as well. But I don't want to trace out this whole thing, remember, because I'm doing a I'm doing a section view, so it's not going to be this whole object, so it's not going to be that whole shape. I know that it is going to be the whole, these two sides, because the sides are solid. Basically, we're looking at this view right here, but cut in the middle. Half of it is cut right in the middle. So we do see those two sides, and basically we see it going straight across the bottom. I don't think there's anything protruding out the bottom, so I can go ahead and finish that bottom. And then I see it going straight across the top until it gets to these two divots, this one and this one, all that stuff there. So I go across the top until I get there, and on the other side I go across the top until I get there, which is where it starts to go in. And you know that it goes in on our section line because the section line is right through the middle there. So the section line does go down, section view does go down. Honestly, up here it looks kind of like a taper, which is confusing to me. It looks like it's extruding with taper, but over here, if it was extruding with taper, it would kind of look like this on this on these object lines here on this view, but it's not doing that. So I'm just going to trust the views that we have. I'm going to trust this top-down view and assume that it's not extruding with taper. It's just straight extrude cut down. So I know that it goes straight down some distance there, but I don't know how long. This is how you have to interpret over here. I know that this is very, very wide. If I'm looking at it from this view, that's what that is right there. That's the right side view. If I'm looking at that, I know that it's very, very wide right here, this hidden line there. So I think that that is the depth of that trough here. So it goes all the way down to there, and then it starts to cut across. Now, I see that it's I can cut across until that hole, and I know that that hole right here starts to go down. How far down? Well, I know that it's skinny, okay? So basically, let me clear up some of my space here. I'm looking at two different objects. I'm looking at this hole, and I'm looking at this divot here. I have two different things here, and I'm thinking that since that divot is wider from the right face, that's that purple divot there, whereas the red one is this long skinny hole. Okay, so I think the long skinny hole is a through all. I'm going to keep my color coordination going here. I think that that's through all. And in fact, if that is through all, I think we would end up dropping this object line all the way through there, and we'd get kind of a segmented view there, segmented at the bottom. Okay. So I redrew my object line at the bottom, and that hole goes up there at the through all. So that goes over until I hit the edge of I'm still inside the bottom of the trough there. I go over until I hit the edge of this the cylinder sticking up. Pretty easy to know how far up it goes. It goes up until I see it on the right side view, and I go across. Does it go back down into the trough? Yes, so I go down that far. I go over, and then I come back up to my surface because I'm done with the trough at that point. I can go over until I hit the next indentation. This is this weird little divot here, this window-shaped looking divot. And like I said before, I colored it purple because I think that it's the one that goes down to that level. We don't have anything at that level yet. We'll go over, and then from this view, from this front view, it looks like it's it looks like a rectangle. We can't tell that that's a curve from this view. All we can see is this rectangle right here because it slices it right in half. We can kind of see where the curve stops. That would be at this section line right here that we don't have anything on, but that wouldn't be a feature. That wouldn't be an object line on this view. It would just be object lines just like this. All right, and this is what you should have for question 1. Should I do question 2? I don't know. Maybe you can do it, and then I'll post the answer key later. All right, well, have a good night.